Interesting. The artist used points, lines, and planes. There's a point right here, there's lines, and there's a plane in the middle. These two lines intersect at the point. Interesting.
Say, come on over.
This is a point. A point has neither shape or size, but it is drawn like a dot. It is named by a capital letter, so we will name this dot dot A. This is a line. A line is made up of points and extends forever. You can name a line by using any 2 points on a line or using a lowercase cursive letter. This line, for example, would be called line AB or line L. This is a plane. A plane is a 2D figure that goes on forever. Since it is impossible to draw a 2D figure that goes on forever, we draw a quadrilateral. It is named by a capital cursive letter. 2 lines intersect at a point, and 2 planes intersect at a line.
Baby, we'll be baking a cake for you. I swear I'd fall in love every minute on the street. You might be walking around the corner. And it's perfect.
What do we have here? The use of polyhedra and non-polyhedra in one painting is amazing. What do we have here? A triangular prism, a rectangular prism, and a cube, all in one painting. Those are all polyhedra. And right here, that is a cylinder, a non-polyhedra. I wonder how you find the volume of this polyhedra.
I told you.
A polyhedron is a 3-dimensional figure with flat faces, straight edges, and sharp corners. A few examples of this is a cube, a triangular prism, and a pyramid. A few examples of non-polyhedrons are spheres and cylinders.
Interesting methods. The artist used many different mediums to create this work of art. But what is this? The knothole is not centered. The knothole should be equal distances from the edges of the tree. And the knothole should be the midpoint of the trunk. Horrifying. What has the art world come to these days?
To find the distance between the 2 points in our previous example, we would use this formula. x2 would be -1, x1 would be 2, y2 would be -3, and y1 would be 2. We add those together, and then we get -3 and -5. Once we square those, we get 9 plus 25, and then once we get the square root of that, we get the square root of 34, and that is our answer. To find the distance between 2 points on the coordinate plane, we use the distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared.
that have a tendency to keep the truth far from our mind.
Our free choice lesson is 3D figures because we think it's an interesting concept. We chose distance and midpoints as our hardest lesson in the chapter because it has the most complicated equations to find the distance and midpoints. We chose points, lines, and planes as our most important lesson in this chapter because it provides a foundation for many other concepts in geometry.